Hey everyone, welcome back to my channel. Today I'm going to tell you why 90% of DevOps engineers fail in CI/CD pipelines and how you can easily fix it. So see the CI/CD tools like Jenkins, Azure DevOps CI/CD, GitHub Actions, GitLab CI/CD. So there are multiple CI/CD tools are there, or AWS Code Build and Code Release, Code Deploy. Okay. So if you are using pipelines, so some scenarios are due to some issues, the pipelines are slow, breaking frequently, or taking hours to deploy. So for all these issues, this is the video for you. So watch till the end and you will learn how topmost companies like Netflix and Amazon makes their pipelines super fast and reliable and flexible. Okay. So I have captured a couple of common problem statements. So why the DevOps engineers fails in CI/CD? Let's go through one by one. So the first problem statement or biggest mistake is not using the pipeline as a code. Many engineers still creating the jobs, creating the builds, creating the deployments manually. Example, if you take that Jenkins, many engineers still create the Jenkins jobs manually using the UI. So every time they need a change, they click around. Once the change is done, they build it, they test it, they can deploy it. All those things they will do it manually. This is old school DevOps. Okay. So the modern way is to write everything as a code. So use a Jenkins file, GitHub Actions, or GitLab CI, or Azure DevOps CI/CD. So your entire pipeline should live inside your repository. So that way you can version control it, you can review it, and easily reproduce the same pipeline anywhere. Okay, so please remember this. If your pipeline isn't in the Git or in the Azure DevOps, it's not real DevOps. Okay, so that is the first problem statement you should have to aware of that. And the second problem statement is building the Docker image is slow. Okay, slow Docker builds. So I have seen so many engineers build Docker images from scratch every single time. That wastes time and bandwidth. Okay, the solution is simple. So instead of doing from the scratch, use the multi-stage builds and Docker caching. So for example, in your Docker file, build your application in one stage and copy only the final artifact to the second stage. So this makes your image smaller and your builds much faster. So and always keep your base image updated. If outdated images means that will be slow down security scans and deployments. Okay. So that is the second problem statement. You should have to use the multi-stage Docker build. And the third mistake is YAML files held into the Kubernetes. Okay. Many beginners copy and paste Kubernetes YAML files from the internet without understanding what is inside. So that time, if we can copy paste automatically, the result will be broken the deployments and messy clusters. Okay. So instead of this, so using Helm, just we can create the templates based on our requirement and we can reuse them for multiple environments like dev environment, staging and production wherever it is required. That means we can use fewer files and fewer mistakes and cleaner deployments. We no need to use that more files, only few files is enough actually. So these are the couple of problem statements most of the DevOps engineers fails into the CI/CD. Okay, how we can overcome these problem statement? So now this is where we need to maintain the quality gates in the pipeline. So this is where we need to add a quality gate in our CI/CD pipeline. That means before deployment, your code should automatically pass through unit test cases, some security scannings, and some quality testing and performance checks. So all those things should be passed in the CI/CD pipeline. So this process is called as a shift left testing. So in the shift left testing, we catching the problems early in the pipeline before they reach to the production. So this is exactly how companies like Netflix, Amazon, and Google maintain the super stable deployments. Okay, now let me show you one sample demo. How easy to create a simple CI/CD pipeline using GitHub Actions. Okay, let's say you have a Node.js application. Create a file called .github/workflows/cicd.yaml. So there you need to add the following code. So in this code, just what I'm doing is every time you push the code, GitHub Actions will be automatically build your Docker image and deploy it into the Kubernetes. So this way, if you do fast and simple and fully automated, that is the modern deployment. So here I used that. The agent should be Ubuntu latest and it will do the checkout. Then it will do the Docker build. And this is demo app :latest. This is the image. And we can deploy into the Kubernetes cluster. Now let me show you how the deployment YAML file look like. Okay, this is a deployment.yaml. So here the example, you have a Docker image called demo app :latest. Okay, so and you are deploying it into the Kubernetes cluster that was built by using GitHub Actions. Okay, in the same GitHub Actions, we use it to put deployment.yaml. Okay, so this deployment.yaml file defines how containerized applications should be deployed, managed, and exposed a Kubernetes cluster. It is actually contains two Kubernetes objects. One is called deployment, another one is called service. So, deployment controls how pods are created and managed. Service exposes the pods to users or other services. So in this deployment section, the basic structure is there is a API version defined and kind. Kind means define what type of object and metadata. Okay, so in this metadata includes identify the information such as name and labels. The label app::demo app helps Kubernetes find and group the related resources like services and parts. And in the spec section, I have given two replicas. Kubernetes will maintain exactly two running pods for high availability. Then I have given for the selectors, ensures the deployment manages only pods with the matched labels. That is called demo app. Then I have defined for the pod template. So this is where every pod created by this deployment will have the label called demo app. This label link it to the service. Okay, because so using that we can able to access service. Then we have to define for the container spec. So where a pod can have multiple containers. Here we used one name which is called demo, that is called container, and image will be referred, the Docker image which we built from the GitHub Actions, that will be tagged as demo app :latest, and I have defined for that image pull policy. So if not present means only pull the image if it is not already is there in the respective node. Then I have defined for the ports. Okay, then after I have defined for the resource limit. Okay, so port I have exported for the 8080. Okay, the cluster that will be exposed to the cluster network. And resource management I have defined where is a request and limits. A request means the minimum CPU and memory that the container requires, and limit means the maximum CPU and memory the container can use it. That will be helps prevent one pod from the overusing cluster resources. Then I have defined for the probes, which is called health checks. So there I have defined for the liveness probe and readiness probe. Liveness probe means check if the container is still alive. If it is fails repeatedly, Kubernetes automatically restart the pod. Readiness probe, that will check if the container is ready to serve the traffic. If not, Kubernetes won't send the traffic to it until it is ready state. Okay, so both probes call the root path with the port of 8080. So that is where I have given the path here, root. So these are the critical in production actually. They make sure your deployment, self-healing and reliable, it will be maintained. Then coming to the service section, so here this part exposes the application to the outside the world. That means end users can able to access. So same way API server kind of have defined type of the object and selector. This must be match the app which is called demo app label from the deployment pod. Okay, it tells the service which part to forward to the traffic based on the label. Then expose the ports. Okay, so port 80 exposes the service inside the cluster. Target port is 8080. Forwards the traffic to the container port. So here type of the service we are using node port. So exposes the application on static port on each cluster node. That range should be 30,000 to the 32,767 should be there. So you can access your app which is called demo app through node IP colon node port. So this is how this should be work actually. So just take this. I will post this into the description. You can take this and you can test it. Okay. So after that, so using kubectl apply -f deployment.yaml. This will we already defined in the GitHub Actions. So the conclusion is now you know why most of the DevOps engineer fails into the CI/CD, because they did not automate, they build slow Docker images, and they ignore the best practices. But you are not like that anymore. You are in the top 10% now. If you learn something new today, please hit the like button and comment and subscribe for more real world DevOps tutorial for every week. Thanks for watching.